Alright, as we go ahead and take a look at example 2, example 2 says that line N is parallel to line P, and we're supposed to find the measure of each angle. To start off here, we're going to talk about angle 2 in this illustration. As you can see, angle 2 is right here. Well, I'm going to ignore half of this diagram for a minute because I really don't need it right now. I only need the left side to do what I'm about to teach you here. Covering up that right side, what you can see we have left is basically kind of an oblong X shape. It's extended out, but it's an X shape. Well, when you have that X shape, you create a couple different types of angles that we talked about here in the definitions. If we look at the top piece of the illustration here, those two angles together, right? Those two angles together end up forming together a line. All right, if we ignore the line that juts north-south there, all right, they make a line. So they have to make 180 degrees together. That's the idea of two angles being supplementary. Again, supplementary implies that two angles add up to 180 degrees, or together they form a line. What's more important from the definitions you saw today is that they are also adjacent angles. They're adjacent angles because they happen to share a side. This side right here. Now the same thing is true for the angle marked 3. Sometimes it's a little bit harder to see there, all right, but it goes the same way there because running up down there, kind of diagonally across the page there, you have two angles together that form a line that make 180 degrees. That means they're also supplementary. That means they would also be adjacent because they happen to share a side, which is this one right here. Well, that's more important for me because 3 is one of the angles they're asking me to find. But the same logic will apply to finding angle 1 if we were asked to. Since these guys are adjacent supplementary angles, that means they have to add up to 180. So if this part is 130, then each one of these angles here happens to measure out to be 50 degrees. So to answer for angle 3 has to be 50 degrees. Now, let's realize here that we've now shown a relationship between angle 1 and angle 3 because angle 1 and angle 3 both happen to be 50 degrees. Well, what's true here is that these angles are across from each other in that X shape. That's called vertical angles, which is another term we defined today here. What you have to know about vertical angles is vertical angles have the property of congruence. So angles that are across from each other in that X shape are always going to have the same measure. Well, that's great because now I can find angle 2 really easily because it's across from this 130 degree angle in the X shape. So if I know that this is 130 degrees, this is also 130 degrees. So here they're saying to find angle 2, since these two guys are vertical angles, and vertical angles have the property of congruence. Remember, congruent means the same. It's just the geometry way to say the same. In numbers, we say equal. In geometry, we say congruent. Since these two angles are vertical angles, and vertical angles have the property of congruence, angle 2 has to measure 130 degrees. Now, you might notice here, they found angle 3 a little different way than what we explained here. There's one other type of angle relationship with parallel lines that's really important for you to understand, and that's the idea of corresponding angles. The two angles that we're concerned with, the one that was marked 50 when we started, and the one that we found to be 50 after we did a little bit of calculation, some simple calculation, those guys are called corresponding angles. Corresponding simply means they're in the same relative location. What do I mean? Well, those two angles share a relationship. What's true about both of those angles is they're beneath this line here, which is called the transversal. That was another term you defined today there. Transversal is simply a line that cuts across parallel lines. All right, that's all it is. So both of these angles that I've now highlighted are beneath the transversal, and both of them are to the right of a parallel line. Those are called corresponding angles, and we can do that with any pair we want. We've got a set that's both beneath and to the left. We've got a set that's both above the transversal and to the left of a parallel line. We've got a set that's both above the transversal and to the right of the parallel line. Again, lots of different possibilities there. But what's most important here is the two we're talking about here that are both beneath the transversal and to the right of the parallel lines, the ones I've highlighted. Those are a set of corresponding angles. Corresponding angles also have the property of congruence. So if I know one, I know both. So what they did here to prove angle 3 is 50 degrees is they said since this guy is 50, and these have to correspond because they're both beneath the transversal and to the right of a parallel line, that means this guy is also 50 degrees. And of course we vetted that out by using the adjacent supplementary angles here to find that the sum is 180 and this one must be 50. So there's lots of different ways to prove the relationships here. Now the idea of corresponding, however, only works with parallel lines. You can get the idea of angles being next to each other to work all the time. You can get the idea of angles adding up to make a line all the time if they happen to make a line. But the idea of corresponding only works if you have parallel lines. Alright, and with that out of the way, we're ready to go ahead and take a look at the concluding examples here. Number 1, we're supposed to tell whether the lines appear parallel, perpendicular, or skew. So taking a look at this particular question here, we've got WX and ZY. Well, as you can see here, WX here is on the left side of the fence. ZY is on